Hey guys, so it's me doing another video. Sorry about the audio on the last one. I couldn't figure out how to get it to work, so I'm just gonna redo it. Um, so here for this problem, which is similar to the homework problem 87, for each pair of numbers below, we need to find a quadratic equation that has these numbers as solutions. Or, remember equally, roots. It means the same thing. Okay? So, from class, if you remember, if we start with a quadratic, we're going to start with x squared plus yada yada yada. Now, if we were to factor this, it'd be x minus some number times x minus another number. And of course, the solutions would be in the form x equals blank or x equals another blank. And this comes from the zero product property. So that's what we're doing here, except we're going backwards. We got the solutions and we're trying to get the equation. All right, so let me erase all of this stuff. All right, so if my solutions, I'm gonna do the first one here, are 3/4 and -5, that means I start with this. Now over here for the right hand one, it's easy because all we have to do is add a 5 to both sides. So then x plus 5 is one of my factors. Over here we're going to solve for the right hand side of this equation by multiplying by 4 first. So 4x equals 3. And then we'll move the 3 to the other side. So 4x minus 3 is another factor. So an equation for this quadratic could be y equals x plus 5 times 4x minus 3. Okay? And of course I can multiply these out if I wanted to, doing the FOIL method, or I could use generic rectangle, whatever I want to use. Okay? Same deal here. Get the factors, multiply them out. For complex solutions or roots, it's better to multiply them out using FOIL or the generic rectangle, because in the end you won't have any imaginary numbers running around. So I'll leave that to you guys. Let's jump on to number C, or letter C. Again, if one of my solutions is x equals 5 plus 2i, and the other solution is x equals 5 minus 2i. Now these are conjugates. Now when we're solving a quadratic and it's got complex solutions, they usually come in conjugates, and these two here are conjugates. The only difference here is the subtraction sign and the addition sign. That is the only difference. Same deal though. If I want to solve for, or if I want to find the factors, let's find the factor of this guy. Well, all I do is move everything to the other side. So x minus 5 and minus 2i is one of my factors. How did I get that? Well, let's not jump any steps here. So I'm going to move the 5 to the other side by subtracting by 5. So x minus 5 equals 2i. And of course, in the end, I'll move the 2i to the other side. So x minus 5 minus 2i is one of my factors. Same deal over here. So I'm not going to show every single step. I'll let you guys figure that out. I'm sorry. So x, excuse my x, that's terrible. So x minus 5 and plus 2i is another one of my factors. Now, like I said, for complex solutions, what we want to do is multiply them out because the i's cancel out. Let me show you what I mean. Okay, so I'm going to make a generic rectangle here. because I think it's simpler to do the generic rectangle for trinomials like these two guys. So I'm doing x minus 5 minus 2i, and then x minus 5 plus 2i. That guy is right over there, and this dude is right there, okay? Just in case you're wondering. All right, so let's multiply them out. So x squared minus 5x, and then minus 2xi. Great. Now over here I have minus 5x plus 25, and then plus 10i. Now over here I have plus 2xi, or whatever. Now I guess I could say 2xi. Remember, multiplication is commutative. But notice that I wrote this the same as that, and they're negative, so they cancel out. So I made a mistake. I actually wanted to put 2ix, but I wrote 2xi. So same deal. You guys know what I mean here. So minus 10i, because negative 5 times positive 2i is negative 10i, and notice that there's the positive 10i there, negative 10i, and so those will cancel out in the end. And of course, negative 2i times positive 2i becomes negative 4i squared. Again, I'm going to cancel these guys out and these two dudes. And so in the end, I have x squared minus 10x plus 25. And of course, this part right there, we know, if I'm gonna move it over here, we know that that is negative 4, and I squared is just negative 1, so plus 4, because negative times a negative is a positive. So x squared minus 10x plus 29 will be the equation for a polynomial that has these guys as roots or solutions. I hope this helps, guys. Have a great day.